Hey, thanks for checking out my talk. I'm Alex Kitchens recording from home, and today we're going to build a Rails controller from scratch. We'll go about it this way. I have a really simple Rails blog app with a really simple model. It has two basic controllers, both for posts. The first one is a web version, and the second is an API version. Both have a test suite to ensure that they're working correctly. This is what we're going to do. We're going to replace the inheritance of our controllers from inheriting from ActionController to inheriting from an implementation of our own. Then we'll see what we have to build in ActionController's place to get the app working correctly again. We'll build two controller base classes. AwesomeController base, which is a replacement for ActionController base that will respond to web-specific requests, and AwesomeController API, which is a replacement for ActionController API. If you've never used ActionController API, it's a stripped-down version of stripped-down controller class that Rails provides to respond to non-web requests like JSON. At the end of this talk, I'll share a link to where you can see the code I've written, and you can play around with it next to the real Action controller. The code written in this talk is not meant to reinvent the wheel, and it will sort of mimic the code of ActionController. My intention with this is to give you an insight into the real code of ActionController, while taking freedom to simplify it for learning's sake. In the end, we'll have two controller classes that collectively handle four things, or rather four modules. In comparison, ActionController API has 15 modules. And ActionController base has a total of 35 modules. So clearly that this is a very minimal happy version path, but by doing so, by building something like this, it will help us understand the inner workings of ActionController. This talk was originally brought on because I realized that I don't know a whole lot about what a controller actually does. I got the basic concepts of a Rails request response process, but that was pretty minimal. This is what I knew. When a request comes in, at some point it hits the controller and then it returns a response. With an explanation like that, I realized that I knew very little about how a controller receives a request or how it processes that request to create a response. Most of my time with controllers has been spent dealing with writing actions like this. Thanks to the conventions and hard work of ActionController, the controller has always been a really easy part of Rails apps. But my lack of knowledge here and my general curiosity is what inspired this experiment. So here we are. We've got our new inheritances, and we have our new empty base classes that look like this. And we've got a whole load of test failures. This is where I started my journey. What do we have to do to get this test suite back to green? There's a lot of test failures, but the most common is this, an undefined method called dispatch for both controller classes. It turns out it's coming from when the router sends the request to the controller. The router gives the controller the request, and in return it expects the details of the response from the controller. It does this by calling dispatch on the controller class. Our controller doesn't have this method yet. Here's the actual line of code in the router where it was failing. When the router calls dispatch on the controller, it provides it with three things. The first is the action that the controller should call, and the action is in the form of a string, for instance, show. The second is the request object. This object is essentially a wrapper around the details of the request. The details of the request live in a hash that looks like this, giving you details on like the path info, parameters, and other data provided by the original request. The last piece is an empty response object that makes it easy to get and set data for the response. The router provides all of that information, and in return, it needs to know these three things from the dispatch method: the status code, headers, and body of the response. This information will come from the response object that the router gave to us, and the response object comes with some defaults for each of these, notably a 200 status code and an empty body. The response has a handy way of getting that data. If I call the toArray method on the response, then it will give me these details that I need to return. Knowing that this is the point of failure, we can start to build out our implementation. I've defined a class method called dispatch, taking in the arguments from the router, and I've used the response to send back the status code, headers, and body of the response. This supplies us with the start of our implementation of dispatching the request to the controller and returning a response. Now, because this method is needed for both the API and base controller classes, I've implemented it instead in a superclass for them to inherit from, and I've named it SuperBase. With the base classes inheriting from it, they'll share this implementation. And this code fixes the fact that dispatch has an undefined method. We can rerun the tests, which will continue to fail, but for many other reasons. We'll start with this easy one, a failure due to an empty response body from our API. The response is empty because we're providing the default empty body of the response object, which is good. This means that our method is being called and our empty response is returning its data. We still have not called our action, so there's nothing to process or render. That's our next step. We have our action method name as a string provided by the router, and we need to call that from in here. But there's a little problem. Our dispatch method is at the class level of the controller, but the show method in our controller is an instance method. A simple way to fix this is to move the main dispatch functionality to an instance dispatch method and simply delegate to it through a new controller instance in the class method. This was an important note for me because at one point I had a light bulb moment and realized that at any time I'm interacting with the controller in my apps, like say in an action method, I'm typically interacting with an instance of that class. So we have this instance method of dispatch. Since we have a new instance, we can save the arguments as instance methods so that we can access them whenever we need to. This will be helpful since the controller's role involves processing a request and response. Now we need to call our action. Ruby has a couple of ways of calling a method. Say we have a class called greeting, and it has an instance method hello, and we have an instance of that class. We can call it in a familiar way, the dot method format, which is here is greeting.hello. This will call the method, return the expected string, hello, how are you today? Ruby has another way to send the method, which is using the send method. If we supply the send method with the name of the method we want to call, either as a string or a symbol, it will call the method. Doing this again will call it and return the expected string, hello, how are you today? So knowing this, we can use the send method here to call the action. And this gets us what we want from the dispatch method. With this collective code, we now have base and API controller classes responding to router requests, calling the actions in our controllers, and returning the status, headers, and body of our response to the router. And because we are dispatching requests correctly to our controllers, we still have failures, but they're new failures. Here are two from the API controller, both undefined, one for params and one for render. Both are due to the fact that our controllers reference params and render, but our base classes don't have an implementation of either. We'll start with implementing params. Params is a nice abstraction that ActionController provides for accessing the parameters of a request, allowing you to grab some directly, require some data in the params, or permit attributes to be passed on to models or classes. The request stores param information on itself in a hash with indifferent access. Here are the params for calling the show endpoint for an API within the request. These two uses of params occur throughout our app's controller, so we have two corresponding failures for params. For the first failure, given that the request provides parameters in a hash, we're in luck. For this, simply pulling an ID from that hash suffices. If we want to get the params for that kind of method, we can simply write a method like this. I put this method into a params module. This module can be included in our base controller classes like this. Now this begs the question, why put the code into a module and not directly into our classes or our controller base classes or super base? The main reason is I put it into a module because modules allow the ability to create code boundaries. My API class wants to know what it means to be an API. Does it need to know about params? Sure. And I could include the code there, but should it be responsible for those details? Probably not. By providing a params module, I'm saying that these methods and this code provides behavior related to params. This allows me to include it in my API controller class, extending that functionality, and focus solely on creating methods in my base class or super base class that are direct responsibilities of that class. This is using modules is another way of sharing code. Both the API and base classes will include this module and its functionality. Our module and its methods pass our first params test, but our use of strong parameters is still failing. We need a better implementation in order to make a call to params like this work. One that takes parameters like this, ensures that the required attributes exist, and filters out unpermitted attributes. Because require and permit are not methods that exist for hashing within different access, we need to create an abstraction over the request params hash. In order to keep our current working version happy, we can write something like this. Basically, what we have here is a new parameters class. It's initialized by storing the parameters hash as an instance variable, and we write the hash access method to pull from that params instance variable. Then, our params method simply returns a new parameters object. This provides us with our currently expected needs. Our next step is to implement require. When we call require, we're saying this thing, here being post, must be in the top level of the params hash. And if it is, return its values. If the item that we're requiring is not there, like say we required author for this hash, then it should raise an error. This is a lot like hash's fetch method, where if the key is provided, it returns the data for that key, and if it's not, then it raises an error. To get a basic working implementation, we can implement this method using fetch. That may look like this, but we need to make sure that what it returns can also respond to permit. This is as simple as wrapping the results of the fetch in an instance of parameters. This gets us to a working functionality for require. Next, we need to implement permit. Similar to require, thinking about what permit does, it says, these are the attributes that you're allowed to pass in. And if you provide something else, we will filter it out. If we took this hash and said only permit the title, then it should return a hash containing only the title. For implementing this, since we're passing in an array of attributes, we can define the method to take in an array of attributes. And in the method, we can use Ruby's select method to filter the params where the key belongs in that list, looking like this. And like that, we have a passing implementation of params. Our end code looks something like this, with direct access, require, and permit implemented. And this leaves us with our render failure for our API specs. And in order to reproduce render, let's think of what it means in terms of updating our response object and what the response object will return to the router. We know that we want this hash to be the body of the response in a JSON encoded string. And we want the provided status to be the status code of the response. Since this is a JSON response, we also want to update the content type to be JSON in the headers. This means that in our render implementation, we need to supply the response object with these three things: the status, the content type, and body. This code can become the beginning of our rendering module. We can start implementing the status code. The status is not something we always set when rendering JSON. For instance, here, when rendering the JSON for a single post, I don't specify a status code, and instead depend on the default 200 status code for the response. Since status will not always be provided, we can set this as an optional argument. And if the argument is provided, then we can set the status on the response. It's as simple as that. We don't actually have to worry about if we've set the status as symbol or the actual status code number. Either works because when the status is set on the response object uses a mapper provided by rack that translates the symbol to its integer status code. Next, setting the content type is as easy as using the content type setter provided by the response. Lastly, we need to set the body. We need to take this hash and turn it into a JSON string like this. This is as easy as calling .toJSON on the hash. And we can set it on the response like this. This makes the body setting look like this. And like that, we have a working render method in our API. We can include this into the API class. And with our params and rendering modules defined, along with dispatching for our controllers, we have a working implementation of AwesomeController API. This means we finally have our API test passing. And it's processing JSON responses just as it had before. This leaves us with the web portion of the application to tackle. There's a lot of complexity to rendering web requests that API requests may not typically have. For starters, the web controllers of the app failed because we did not have an implementation of controller callbacks like before action. They also failed because nothing was rendering, just like in our API. The rendering issue is due to the fact that in our web controllers, we're not calling render explicitly like we were in the API controllers. So what we've built for our API will not work in our web requests. This meant that I needed two new features, controller callbacks and a thing called implicit rendering. Controller callbacks are the easier concept to start out with. They allow you to run certain methods before, after, or around action methods. They are similar to how callbacks can be set for active record models. This similarity isn't a coincidence. Both types of callbacks take advantage of a built-in Rails callback functionality provided through active support called Callbacks. The active support callbacks API has three major features. The first is defining a callback set. This will allow us to define a set of callbacks specific to controllers. Once we have a callback set, the next feature allows us to add callbacks to it. And the last feature is actually running the callbacks. ActionController and Active Record provide abstractions so that we only have to do one of these things in our controllers and models, which is adding a callback to the set. This is what happens when your controller has a before action. But even then, the method before action is a controller method, an abstraction over the active support API, which we'll see. We'll start by creating our callbacks module, including the active support callbacks module in our module so that we can use its behavior. We need to define our callback set, which we'll name here controller callbacks. Next, since we have a set, we want to add our callbacks to that set, and that takes the form of writing our before, after, and action around action methods. We'll just use before action as an example. In order to implement before action, we need to set the callback using the callback API's set callback method. Here's an example of our before action and what the corresponding set callback call would look like. In set callback, we set the action in the right callback set it as a before callback, and set the provided method name from the before action statement. The method definition would look something like this. In the end, we would also have around and after action methods, but their definitions only differ by before, around, and after keywords. Before we finish with callbacks, we actually have to run them. In order to do that, let's think of it at a high level about how callbacks are called. We have our dispatch method. And we know that before actions run before the action. So let's create a fake method to call our before actions. Around actions run around the action, yielding to it at some point. And after actions run after the action. This is essentially where callbacks run. If we wanted to clean up the logic here, we could extract the callback handling to one method and have an all-encompassing callbacks method like this, where it calls the before actions, around actions, yields, and then the after actions. And we'd call that method in our controller instance like this. This is exactly what run callbacks method does, provided by active support callbacks. This would run our callbacks. Except we have written our callbacks code into its own callbacks module, and we want to continue to do that here. In order to run the callbacks in this method without putting the code directly here in the method, we need to have a place where we can hook our callbacks into this dispatch method. We can provide a hook for sendAction by moving the sendAction into its own method in our base class and then calling it in dispatch. Here we define a process method whose job is to make that sendAction call. Then in our module, we can define a process method, which will run the callbacks and super onto the next thing. This will work because when process is called in our AwesomeController base, it will first go to the process methods defined in the modules included in the class. That will hit our callbacks process method, which starts running callbacks, then supers to the next definition of process, which is the definition in our base class. In the end, this is what the code looks like for our callbacks module, which we can include in our AwesomeController base class, and this gives us a working definition of callbacks in base. This leaves us with our final problem. The web pages are not rendering anything. They essentially look like this empty slide. That's because they're not calling render. We need to implement the concept of implicit rendering. Implicit rendering means that you can have code like this in a controller, never call render, yet the response will still have a rendered body. In order to implement this, we need to know when calling sendAction renders something. And if it doesn't, we need to perform a default kind of render. Here again, we can take advantage of the new process method. We can create an implicit rendering module that defines the method process, and we want it to super, or let other processes do their thing. And when it comes back to this method, and nothing has been rendered, then we will perform render. We can do so by tracking when rendering has happened, using an instance variable when rendering, and setting it to true at the end of rendering. In our implicit rendering module, we can replace this to-do with a check to see if rendering has happened using that new instance variable. If it hasn't, then we can call render. I've put the render as to-do here because we have not built render for our ActionController base. The rendering here has a major dependency that's non-trivial to implement, which is actually rendering HTML. HTML rendering is a very different beast. Where JSON rendering incorporates essentially this, turning something into a JSON string, for HTML rendering, there may be several pieces to render one page. This on our own would be a very big lift to implement. Thankfully, we don't have to take on that lift. Instead, we can depend heavily on another Rails module called ActionView. ActionView is what manages layouts, templates, and HTML rendering in Rails. Specifically, we can use a module in ActionView called rendering that provides some methods which, when given the right arguments, will do the heavy work to render the HTML. Getting the controller plugged into ActionView required a lot of configurations, so instead of going through that, I will share some of the highlights of what was required. The first was providing ActionView with the view paths for our controllers. ActionView needs to know where the layouts and templates live for our controller classes, and because the views are the same as before, we just tell ActionView that they live in @views. Next, it needs to know the variables to assign to the view. I thought this was specifically cool because it needs to pass on variables from the controller to the view, and I'd wondered about how this works for a long time. First, getting the instance variables from the controller is as easy as calling the method instance variables from inside of the controller. We can pass those instance variables to the view by creating a hash of them, setting the key as the instance variable name, and the value as the actual value of the instance variable. When ActionView receives this hash, it does the exact opposite. It takes the key and value and makes an instance variable with the key name and provided value. And there, the controller has shared its instance variables with the view. There are several methods that needed to be defined in order to work with the ActionView rendering module, and all in all, the rendering code spread across 2 modules. When given all these details and method definitions, I was able to call render_to_body, provided by the ActionView rendering module, which gave back the rendered HTML as a string. And it looked something like this. We can take a glimpse at how ActionView rendered that. It was really cool. ActionView takes a template like this and turns it into a unique method. Notice how the method contains the view's name in it. If we zoom in on a part of it, say the rendering of this post title, it separates the strings or the hard-coded parts of the template out from the variable or method calls. Then it takes each line and appends it to a buffer. At the very end, it turns that buffer into a string, which we can happily set as the response body, which rendered with its CSS looks a little something like this. And with all of that, we have a working web controller. And all of our tests are now passing. Now, I may have been ambitious with the name AwesomeController. Minimum Controller may have been a little more fitting, or even cool idea, but don't really use this in production controller. Still, the code written here touches on the major concepts of a controller. At the heart of a controller are the request and the response, and everything the controller does is related to those two things. And while the code does not suffice for running in production, I hope that for you, the concepts open some new windows of understanding controllers, their modules, and behaviors, and the part that they play in the Rails request lifecycle. Thank you for watching my talk. The code lives here in GitHub. Please take a look at it and play around with it. That's what I made it for, and the code is what helped me get through this talk. There are several other modules included that I was not able to go through, and I hope you also take a look at those. The repo also includes Puma, Rails, and Rack repos in the dependencies folder, so that you can throw a binding nut pry in those and play around with it. And the repo also includes the pry by bug gem. I found this useful because sometimes I like to drop into the code and then step my way through it. And lastly, don't stop there. Dig through the controller code in Rails, which lives in the Action Pack module, and I guarantee you'll come out with a few new learnings. If you found this talk helpful, please reach out to me and let me know. I'm on Twitter. It has been something I've played around with for a long time, and so I would love to know if this talk actually helped you. Thank you again.